Welcome back everyone. On my screen you can see the sales and profit data of a company categorized by country, product, manager and the date of each order. Now let's say you want to find out the total sales generated by each product. Most of us would immediately go for a pivot table like this and drag product into rows and sales into values to get the sales for each product, right? And if you are not familiar with pivot tables, don't worry, I have made a separate video on that and you can find it in the description below. Now while pivot tables are very useful, they do have some downsides. If you change your source data, the pivot table doesn't update automatically. You have to manually refresh it. For example, if I increase this sales value drastically, the pivot table won't reflect the change right away. To fix that, you need to right click on the pivot table and choose refresh. Now you see the updated numbers. You can also refresh it from the pivot table analyze tab and just click on refresh button from there. Now let me undo that by pressing Ctrl Z. Similarly, if you add or delete rows in your dataset, the pivot table won't reflect the change unless you refresh it again. And this is where the new group by function in Excel really helps. Just type equals to group by, select the product column, then select the sales column and finally choose sum from the list of the functions and press enter. So you will get the same result as the pivot table. Now like before, if I increase this sales value drastically, you will notice that group by function reflects them instantly, but the pivot table still won't. Let me undo the change and you will see group by function adjust back immediately as well. No manual refresh needed. Another big advantage is that since group by is a function, so you can easily nest it within other functions or even nest other function inside the group by function, which is something you really can't do with the pivot tables. Alright. One thing to note that this data is presented in a normal range. So when I select the columns, Excel uses the cell references like C2 to C27. But if your data is formatted as a table instead of range, let me show you. Go to the Insert tab, click on Table and hit OK. Now when you use the group by function and select columns, you will notice that Excel uses structured references like product, sales instead of cell ranges. Do you notice the difference between the two? And just to clarify, both ways are correct. You can use either the normal range or a table format, whichever way you prefer. For this tutorial, I will be using the range format to keep things simple. And to convert the table back to a normal range, just go to the table design tab and click on convert to range and that's it. The formatting like colors and borders will still remain, so let me remove that manually. Now let's understand the group by function step by step. The group by function looks a bit long at first, but don't worry, you only need first 3 parameters in most cases. The first 3 parameters, row fields, values and function, are required parameters and the remaining parameters are optional. Optional parameters are shown in Excel in square brackets and you can skip them if you don't need them. The first row fields parameter is the column that contains the value you want to group or summarize by. For example, product, manager or country. Let's say you want to know sales by product. So you will select the product column as your row fields. Think of it like rows section in a pivot table. Next is values. This is the column that contains the actual numbers you want to calculate, like sales or profit. In our case, let's select sales column. Next is function parameter. This tells Excel how to summarize your data. You will see a list of built-in functions like sum, average, max and so on. Let's say you want total sales for each product, then just select sum from the list and press enter. And Excel will give you the total sales for each product, just like a pivot table but directly in the cell with a formula. Now let's say instead of total sales, you want to know the average sales per product. No problem. Just change the function from sum to average like this. Similarly, want to know the maximum sale for each product? You can use max function. You can also try other functions like minimum, count, and so on. Just for now, let's stick with the sum function. Alright, moving ahead, what if I want to group by more than one column? Like, I don't just want product but also country together. It's easy. In the group by function, just select the country and the product columns that you want to group by. You can do that using Ctrl plus drag or just select them as a range and press enter. This time, Excel gives you the total sales for each country and product combination. Similarly, what if you want to summarize by both sales and profit? In that case, just select both columns in the second argument and Excel will apply the sum function to each of them like this. Okay, let me undo that using Ctrl Z and just stick with the sum function for now. Alright, now comes the interesting part. Let's say you also want to include the date column along with these functions. How will you do that? You might try to select all these columns directly in the first parameter, but that will give you an error. Why? Let me first undo that. Because date is not physically located adjacent to the other two columns in the data set. Excel expects the grouping columns to be next to each other if you are selecting them as a block. So how do we fix that? For this, we use HSTACK function like this to virtually stack those non-adjacent columns side by side inside the formula. And now we get the result as expected. So what is HSTACK or horizontal stack function? It is a function in Excel that lets you combine columns horizontally even if they are not next to each other in the sheet. For example, if we have two arrays 1, 2, 3 and 4, 5, 6 not adjacent to each other, then HSTACK function will combine them like this. Likewise, we also have a VStack or vertical stack function which combines or stacks arrays vertically like this. So when we use HSTACK function, it stacks the columns horizontally even if they are not adjacent to each other. Alright, now let's move on to another powerful concept, which is custom logic. So far we have been using common functions from the list like sum, which we have used in our examples. But what if the calculation or logic you need is not available in this list? No problem, you can create your own custom logic using a LAMBDA function. So what is a LAMBDA function? A LAMBDA in Excel is like building your own mini formula that can be reused inside other formulas. Let's say your sales values are large and you want to display them in thousands instead of full numbers. Sure, you can do it by dividing the original sales column by 1000 and that would definitely work. But the purpose here is to show how you can use a LAMBDA function inside a group by function with a simple example that converts values into thousands. Just type the function like this, equals to group by C3 to C27, E3 to E27, HSTACK, sum, then lambda, S, sum function, S and divided by 1000. Close the bracket. Here, S is just a variable that represents each group of sales values, and sum S divided by 1000 tells Excel sum the group and then divided by 1000. And we are using HSTACK function to show two columns side by side, one with total sales and the other one with sales in thousands. Alright, so far we have seen how to use the required parameters of the group by function, row fields, values and function. Now let's talk about the remaining parameters. These are optional, but they can give you more control and flexibility. Let's go through them one by one. First one is field headers, which tells us whether to generate the headers in the output or not. Continuing with the same sales by country product example, This parameter gives you a list of options to choose from depending on what you want to display. If your data already has headers, like in our case, and you want to show headers in the output, then you can set this value to 3 like this. And you can see in the output, the headers are now displayed. Alright, next optional parameters is total depth, which tells us how and where the totals like subtotals and grand totals appear in the output. You might have already noticed that GROUPBY function has been showing a grand total at the bottom of the output by default. That's because Excel sets this automatically even if you don't explicitly specify it. But if you want more control, you can use this total_depth parameter to tell Excel exactly how to display the totals. It accepts these 5 values. 0 for no totals, just group the data. Value 1 for grand totals. And if you set the value of this parameter equals to 2, then Excel will show subtotals for each country and a grand total at the bottom, just like a standard pivot table. But if you use total depth equals to -2, then Excel flips the layout. It will put the subtotals and a grand total at the top before the detailed rows. This flipped layout is especially handy when you are building dashboards or summaries where you want the big picture up front. No need to scroll to the bottom to see the totals. But for now, let's just keep the grand total by setting the value equals to 1. Alright, moving on to the next parameter, sorting_order, which lets you decide how the results should be sorted. Once you have grouped your data and calculated values, you might want to sort the final output. For example, you want to show top performing products first, or you want to arrange them alphabetically. That's where our next parameter, sort order, comes in. By default, Excel sorts the results in ascending order of the first column in your output. So even if you don't specify anything, you might notice the rows appear sorted by that first column. For example, alphabetically by country in our example. But if you want to customize the sorting, use the sort order parameter. This parameter accepts a column number indicating which column of the final output you want to sort by. You can use a positive number like 1, 2, 3 to sort in ascending order, and a negative number like -1, -2 or -3 to sort in descending order, where the number refers to the column position in the GROUPBY output, not in the original data set. For example, you want to sort by sales, which is third column in the ascending order. In that case, just type 3 and Excel will sort by sales from lowest to highest. But wait, are they actually sorted across entire sales column? To check this, we also need subtotals. So let me set the value of total_depth equals to 2. Now if you look closely, you will notice something. The sales values are not sorted across all rows. Instead, they are sorted within each group, such as within each country. So for example, within country Germany, all sales are sorted from lowest to highest. Similarly, within India, they are also sorted individually and so on. And what's more, the countries themselves are also sorted by their subtotal values. That means the country with the lowest subtotal appears at the top, followed by the next one, and the one with the highest total will appear at the bottom. But why is that? Because by default, Excel assumes hierarchical structure, where the first grouping column like country acts like a parent and the sorting happens within those parent groups. So you will notice that within Germany, all sales values are sorted in ascending order. Similarly, within India, the sales values are sorted and so on for each group. But if your goal is to sort the entire sales column, ignoring the hierarchy, you will need to change the value of the last parameter, which is field relationship. Just set this to table or value 1. This tells Excel, hey, treat each row field independently. No parent-child relationship here. In other words, sort everything as a flat data. But why there is an error? Because we still have the subtotals enabled, like total depth equals to 2. That implies a hierarchical structure. So on one hand, we are telling Excel not to treat the fields as hierarchical structure, that is in the table form. But on the other hand, we are asking it to show subtotals in a hierarchical way, which is contradictory. That's why it throws an error. Now let me undo that by pressing Ctrl Z. To fix this, we will remove subtotals and then set field relationship to table or value 1. So the data will be sorted purely in a flat non-hierarchical format. Now when you apply the sort order equals to 3, you will see the entire sales column sorted properly, from lowest to highest regardless of country. Simple, right? Similarly, if you want to sort alphabetically by product, which is second column, just type value as equals to 2. This arranges row by product name in A to Z order. Alright, for now, let me switch back to hierarchical relationship by simply removing the last parameter. Now, since Excel considers hierarchical structure by default, it will go back to sorting within each product group, like we saw earlier. Alright, so far we have grouped the data, calculated totals, added headers, controlled totals, and even sorted the output. The next parameter helps you filter and focus on specific data, which is helpful during your data analysis. Let's say the data contains sales from multiple years, but we only want to see sales from the year 2024. Instead of filtering the table manually, you can do this directly inside the formula. Equals to group by, country range, product range, sales range, sum, and year equals to 2024. So this condition returns a true-false array, and only rows within the year 2024 are grouped and summarized. Other practical examples could be to include the sales only from USA, use country equals to USA. You can also apply multiple filters using asterisk symbol, meaning all condition must be true. For example, to get the sales for 2024 and only from Germany, you can write the formula as year equals to 2024, asterisk mark, and country equals to Germany. So this includes sales only from Germany in the year 2024. Similarly, to apply OR logic, we use the plus symbol. For example, let's say you want to include the sales managed by either manager Alice or Charlie. Write the function as manager equals to Alice plus manager equals to Charlie. And it gives you rows where either manager is Alice or Charlie. So you might have seen that this filter parameter is incredibly useful in data analysis, or when you want your report or dashboard to adjust automatically to certain criteria without applying manually filters on the sheet. Now moving to the final parameter, which is field relationship. We have seen this briefly earlier. This parameter defines how multiple row fields are treated, whether Excel should group them as a hierarchical structure or as an independent flat fields. It accepts two values, 0 for hierarchy, this is the default value, and the other is 1 for table. What's the difference? Hierarchy 0 means the grouping follows a parent-child relationship. For example, if you group by country and then product, then Excel will show products under each country. We have already seen this behavior earlier when we added subtotals to the data that was a result of this hierarchical grouping. And for the other value table, treats each row field independently like flat columns in a table. There is no parent-child structure and subtotals are not shown. So with this, we have briefly touched upon all the parameters of the group by function. But here comes the big question. What if I want my output to look more like a traditional pivot table? where values are spread across both rows and columns, not just listed down one side. For example, instead of listing each country product combination in rows, you might want a format where values of products appear as a column headers and countries down the side. So let me quickly create a pivot table. I will drag country to the rows area and products to the columns area. Well, this is exactly where the new pivot by function comes into play. Let's look at the syntax first. The parameters are quite similar to group by. In fact, the logic is same, but with one major addition, column fields. And this column fields parameter determines which columns are displayed as headers across the top. Let's try an example. To show total sales for each country and product combination, having product fields arranged as columns, use this formula equals to pivot by B3 to B27, C3 to C27, E3 to E27, and sum function. Customizing a bit. And you see that the Excel has returned a pivot table style grid having countries listed vertically as rows, products listed horizontally as columns, and total sales filled in the cells. No manual pivot table needed. Now let's say you want to analyze the sales trend of each product across different years with years as column headers for an easy side-by-side comparison. You can easily do it like this. Equals to pivot by C3 to C27, year G3 to G27, E27. So you now get each product down the side and years across the top, and this is perfect for tracking yearly performance at a glance. Pivot by function also give us similar optional parameters for columns like column depth, column sort order, etc. So overall structure remains similar, but you get more control over the columns, which makes sense, right? Because we are building a pivot style grid now. Just know that the core difference is group by gives you a list and pivot by lets you spread the data across rows and columns like a proper pivot table. Now that brings us to an important question. If pivot by function is like a pivot table in the formula form, do we even need pivot tables anymore? The answer is yes, because pivot tables are still useful in lot of cases. Like if you want to explore your data quickly, you can drag and drop fields and get instant summaries without writing a single formula. And more importantly, slicers. That's one powerful feature pivot tables have. With slicers, you can filter your data interactively, like clicking buttons, which is something group by or pivot by functions can't do right now. Also, if you are someone who prefers working without formulas and just want quick insights, pivot table are still the easiest way to go. Whereas group by and pivot by functions are better when you want real-time updates, no need to refresh anything, and if your data changes, the results update instantly. Secondly, group by and pivot by functions can be nested inside other functions or accept other functions inside them, which is a flexible setup. And if you are performing data analysis and need custom calculations using functions like LAMBDA, HSTACK, filter, which we have seen in our examples, then group by and pivot by functions give you more flexibility right inside your formulas. And these functions are perfect when you are building formula-driven dashboards where everything lies inside the grid. And if you are someone who prefers compact, portable formulas instead of heavy pivot tables, these formulas can be a great fit. So I think it is safe to say that group by and pivot by are powerful additions to Excel. They don't replace pivot tables entirely, but they definitely complement them beautifully. And with that, we come to the end of this tutorial. I hope you found it helpful, and please don't forget to like, share and subscribe for more tutorials like this. Happy learning. Thank you very much.